Soon the European Space Agency ESA will launch its new Earth observation satellite called Aeolus. Using cutting-edge laser technology, Aeolus will provide near real-time observations of wind profiles across the globe. These will improve the accuracy of numerical weather prediction and climate modeling, and advance our understanding of global atmospheric dynamics.
Aeolus is one of the Earth explorers that is going to look at the Earth, trying to understand the wind profiles globally. And that's a first, it doesn't exist yet. The whole idea was that we only have wind measurements on very different small spots on the Earth, and we didn't have it globally. So the mission scientists had been asking for this because it's a gap in our measurement system.
The mission aims to expand our knowledge of our atmosphere and weather systems. Aeolus will achieve this by providing global observations of wind profiles from space, providing data which has never been available before.
It's unknown ground, it's what we call uncharted territory. So we are the first agency trying to get a satellite in orbit that looks at the Earth with a laser and trying to understand the wind profile, so the direction, the height and the wind speed. And therefore improving the weather forecast. Because nowadays we only have at single points balloons that measure the wind, or airplanes that give us some data, or at fixed points, at discrete points. This will look down to the Earth in a polar orbit, will dump every 90 minutes the data to Svalbard. That will be distributed to all the European meteorological institutes. And then when you're sitting at home on your couch, you watch the television and you see a weather forecast that is much better than we have it today.
Aeolus will fly in a sun-synchronized polar orbit 320 kilometers above Earth's surface. Its data will be sent to ESA's Svalbard ground station, located in the archipelago halfway between Norway and the North Pole, every 90 minutes. The satellite's main instrument is Aladdin.
Yes, the way the Aladdin instrument works is to eject an ultraviolet beam down through the atmosphere, and then particles of moisture in the atmosphere at various levels are in motion because of the wind, and the system measures the backscatter from those particles using the Doppler effect and can detect the wind speed at the various altitudes, and that's the way the system operates.
The development of Aeolus has been a long and difficult process, with new and cutting-edge technologies designed, developed and tested on the ground.
It has been a very difficult challenge, let's say. It's a long life, because it exists already for 16 years, the program. And when we first had the part of the instrument, when we switched it on, it worked. Then we put it in vacuum and it stopped working. And no one had realized that we needed oxygen inside the satellite to keep the laser active. So it was quite a challenge, so we had to develop a whole new set of techniques. It's maybe a bit too detailed to go in all the details, but as a lot of technology has been developed to put in this nice little satellite which is behind me.
Aeolus is another ESA Earth Explorer mission aimed at pioneering new technology while providing useful data about our ecosystem. It showcases the technological expertise of the European space industry and ESA's objective of monitoring and understanding the planet we all live on.
The main challenge for us has been within the development of the Aladdin instrument. There's a very high-powered ultraviolet laser system in there that is an inherent part of the instrument. And the technology behind that laser system, the development of a stable laser, high-powered laser beam, and the optics that then focus and divert that beam through the system is very critical, and that's been a very key part of the development. After many years and much hard work across the European industry, we've overcome those problems. We've got some new development through coating technology on the optical surfaces to protect them. And we've now got a stable system that's been fully tested on the ground, and we're ready to go.
The tracking of air pollution is also part of the European Union's Earth observation program, Copernicus. One of the satellites that gave scientists massive amounts of data on atmospheric pollution was ENVISAT. This satellite used several spectrometers to detect ozone and trace gases in our atmosphere. The latest satellite, the Sentinel-5 precursor mission, was recently launched and builds on that legacy of ENVISAT.
So we started this precursor mission because the scientists wanted continuity of data. At the moment, we only have one spacecraft doing that job for us, which is OMI, and OMI is coming towards the end of its lifetime. The next missions that will do this job is Sentinel-4 on metop generation, which will only be launched in early 20s. In the meantime, to ensure a continuity of data, we need Sentinel-5 precursor. It will be the only such mission doing this job until then.
Sentinel-5P is a precursor to the Sentinel-5 mission, which should be launched around 2021. But it's not only a precursor, it's also a gap filler, because it's filling the gap based on the data that we have coming from GOMES, Kirmaki and OMI measurements towards this future Sentinel-4 and Sentinel-5 missions.
Sentinel-5P is the first atmospheric chemistry mission within Copernicus. Its main instrument is a state-of-the-art spectrometer called TROPOME, which will be used to detect trace gases in our atmosphere. With Sentinel-5P and TROPOME, Copernicus will dramatically improve operational atmospheric survey.